So we're going to start with the 1-7. I skipped the first page, so this is the second page on 1-7. We're looking at doing proofs. Proofs are something that is used a lot in geometry. You guys don't have to do proofs like we used to do, where we had to do a model from scratch. A proof is basically just proving that something is true. And so this first part here just kind of explains a little bit what a proof is and uses some algebra to do that for you. And the first example here says William solved an equation for x and wrote justifications for each step of his solutions. Drag the handle to reveal the steps. So this is a pretty neat little thing they have here. You click on this and you can drag it. So the first thing that we have here is the equation. 6 times 14 plus x equals 108. So what would you do first to solve that equation? Well, first of all, in a proof, the very first, the problem, the question itself is called the given. And so you see over here on the right side is we're saying this is the given. This is the problem. That's the given. Okay, now if I slide this thing down, you go to the next step, which is where you would take and you would distribute this. So you would go there and there. And you can see they give you, that'd be 84 plus 6x if I did that. Now, so over here on the right side is where, again, we just write what that means. So what did you do? I used distributive property. So you give the reason over here for why you did it. Matter of fact, these are called the reasons on the right side. These are called the statements on the left side. You'll see that more in a minute. Okay, so the next step in solving this equation is you'd bring the 84 over and you would subtract it. So if I did that, brought the 84 over and subtracted it, that would just be the subtraction property of equality. Some of these are really easy. Really, it's just whatever you do. All right. Now, the next thing they did is they went ahead and they subtracted 108 minus 84, and they got 24. Anytime you add, subtract, multiply, divide, whatever, that is called simplifying. So that's simplify. That's what they wrote there. And then the last step, they actually did this, don't have this last step correct. What you would do next is you would divide by 6 on both sides. And so that should say division property. It should say division, not multiplication, property of equality. Now, by the way, I sent you a worksheet that's got these properties of equalities on it. So if you'll look in your Google Classroom, you'll see those and find those. All right, let's take a look at the bottom part here. Now, A says, are Williams' justifications valid at each step? If not, what might you change? Okay, well, I guess I've already told you what we would change is that it says multiplication on the end there. We should say division. Okay, and then it says, can you justify another series of steps that results in the same solution? So could you do that another way? Well, let me just copy that down. Let me show you another way you could do it. So if I've got the original problem, is there another way? And there is another way to solve this. And this is the thing with proofs, is in proofs, there's more than one way sometimes that you can write a proof and it would be correct. So I have to be careful when we're doing proofs. And actually on the test, we won't do any full proofs. They'll already be partly filled out and you just have to fill in the blanks, something like that. And this is why, because sometimes you can do it multiple ways. If another way I could solve this equation is I could divide by 6 first. If I divide by 6, let's see, then those 6's would cancel, and 108 divided by 6 is what? See, 6 times 10, 6, that'd be 18. And then minus 14 from both sides, and you'll notice we still get x equals 4. So, so your reasons would be different. The first step would be by division property of equality. The second one would be by subtraction property of equality. And the last one would just be simplifying. So that one's actually shorter. And that's true of any proofs, is sometimes you got shorter ways of doing it. The book sometimes does it the shorter way. Sometimes they do it the longer way. That's the only thing I don't like about proofs. All right, so next slide. So vertical angles, this is real simple. Not going to spend a lot of time on it, but remember, if you have two lines that cross, like this line here and this line here, they create four angles, and the angles that are opposite of each other are vertical, like angle 1 and angle 2 are vertical angles. The other set of vertical angles, I'll use a different color here, is angle 3 and angle 4 are vertical. Now, what this is saying, the vertical angle theorem just simply says this, that those vertical angles are congruent to each other. And if you just look at it, it makes sense. They look like it. Matter of fact, look at this little thing that they have over here where you can click on it and you can move these angles. All right. But if you notice, as I keep moving them, the ones that are opposite each other stay equal. The blue and the orangish colored ones there. So that's all that's saying. So we'll go on. But that's what that slide says, is that vertical angles are congruent, or they're equal to each other. Now, here's where we get into real proofs. It says write a two-column proof for this. So you write a proof of a theorem. A theorem is something that has to be proven. All right. A postulate, we're going to find out later, is something that does not have to be proven. It's assumed to be true. We'll look at that in another question. But so a theorem is a conjecture. Now, what's a conjecture? Conjecture is something that it's looking at something and making a statement about that. Conjectures may be true, they may be false. We don't know. We have to prove them. So a theorem is proving a conjecture. All right, so we're proving the vertical angles theorem here. And so I'm just going to click on the solution here and let you see how they do this. All right. Now, a proof, here's a few definitions that come up when I do that. A proof is a convincing argument that uses deductive reasoning. All right. And what is deductive reasoning? It's when you use facts to find the solution. So you look at some facts. You can say, if it is raining outside, or you will get wet, and then or your car will get wet. We can say it that way. And then you would say, it's raining outside, so your car is going to get wet. So just based off of facts, that's what deductive reasoning is. We'll look more of that in a minute. And then a two-column proof is exactly what it says. It has two columns, and it's a proof. The first column is statements, and the second column, so here's the statements, and the second column is the reasons for each one of those statements. Now, again, they have one of those little drag down things here, so I like this. So what are we trying to prove here? We're trying to prove, well, first of all, you always got to have a given. That's over here. You've got a given, and it says angle 1 and angle 2 are vertical angles. That's given to you. And we're trying to prove that angle 1 is congruent to angle 2. So you always start with your given. So if you look at this, now I'm going to drag this down over here. The very first statement is always what your given is. So angle 1 and angle 2 are vertical angles. So if you look in your picture, you're looking at this angle here, angle 1 and angle 2. And you're trying to prove that they are congruent. Well, let's see what they say next. All right. There's two parts in the next one. It says that angle 1 plus angle 3 equals 180 degrees, and angle 2 plus angle 3 equals 180 degrees. Now, how do we know that those equal 180 degrees? Well, if you look at angle 1 and 3 and put them together, that one plus that one, it makes a straight line, and straight line is 180 degrees. And then same thing's true. Let me use a different color here. If I use 2 and 3, put those two together, they make that straight line, so they're 180 degrees. So that's called supplementary angles. Actually, it's called a linear pair, and it's kind of getting ahead of ourselves. We're going to be doing a linear pair in just a moment in the next slide. All right, but that supplementary angles, again, kind of getting ahead of ourselves. Supplementary angles mean they equal 180. That's the bad part about this proof. It's kind of out of place because we haven't talked about supplementary angles yet. Now, transitive property of equality is going to be on that little piece of paper that I gave you, or that, well, actually it's not a piece of paper, it's what I sent to you through Google Classroom, but it has properties of equality on it. And so here's what this is saying. If angle 1 plus angle 3 equals 180, angle 2 plus angle 3 equals 180, then since both of those equal 180, then they have to be equal to each other. So angle 1 plus angle 3 equals angle 2 plus angle 3. That's what transitive property is. If A equals B and B equals C, then A equals C. All right, and then we keep going. Now, um, now if you look at this, look at the third one here where it says 1 plus 3 equals 2 plus 3. So since both of those have 3 in them, if you cancel those out, subtract those, I'm not really canceling, we're subtracting them from each side, it leaves you with angle 1 equals angle 2. Remember that little m means measurement, so measurement of angle 1 equals measurement of angle 2. So that is subtraction. You see the reason, always look at that reason because that's what you got to do in a proof. That's the most important part of a proof, is to be able to tell what the reason is. All right, now since those two angles, it says their measurements are equal, then you can say that they're congruent, because the definition of congruent angles, which again, look at, that's your reason over here. Definition of congruent angle says if two angles have the same measurements, then they're equal. And that is a proof. So again, don't get too worried about this. You're not going to have to fill in the whole thing. You just got to fill in different parts. A lot of times you'll just have to fill in the reason side over here. You'll have all this stuff here and you're going to fill in those. Maybe, I know on one of your quizzes, it's actually where you click on it and you drag it over into that space. All right, let's look at the second part here. Now, I'm not going to spend too much time on these because, again, we're not doing a full proof. In a minute, I'm going to let it just pull up there. But here's what I want you to be able to see is look at the given in the proof, and look at the given and what you're trying to prove, and then just kind of walk your way through it without writing it down. So let me show you what I mean. Is the given here is that BD bisects angle CBE. So here's BD over here, and it bisects this angle CBE. Now, you got to know what bisect means. The word bisect means cuts it in half. So we know then, because of that, that this is going to be equal to that. So that's going to, somewhere down here in this proof, we're going to write that this angle is equal to that angle, because that's what it's telling us there. Now, what are we trying to prove? We're trying to prove that angle ABD is equal to, so let me see, ABD would go from here to there. ABD is that purple angle there, is equal to, or congruent to, is actually what it says, congruent to FBD. And FBD goes from, I'm going to use purple again, goes from here to here. Okay. So you can kind of see what you got to prove. You got to prove, I know there's a lot on there, so let me erase some of that. And so here's what we need to know, basically. We need to know that this angle is equal to that one, and that this angle is equal to that one. Because, again, back to the purple, if this blue plus that red is the whole purple, and this blue plus that red is the whole purple, so if the blue and red are equal to the blue and red here, then the purple is equal because it's the same thing. So that's the concept that they're going to do. So I'm going to just let them answer the question here. I'm not going to, I'm just going to put in something just to get it to pop up the answer here. And we'll look at their answer and see how it compares to what we needed to do. Okay, so here's their answer. Now, you look down through here, and it's quite a long answer, isn't it? But here's what they end up doing, is they're going to go through and they're going to tell you that these two blue angles are equal. Why? Because they're vertical angles. They're going to tell you that these two red angles are equal because this angle is bisected, and bisected means cut into two equal parts. And then they're going to say that this blue plus this red is equal to this blue plus this red, so it's equal to the whole thing. So how do they do that? Well, if you just kind of read down through there, you're going to see that the first thing they do is they say that this angle is congruent to that angle. That's the two little angles. Can't really see that up there. The picture, I don't like that. I can't. Here we go. I can move that up a little bit. All right, so this one here is saying that this angle and that angle are equal. because they're bisected. And then it says that angle ABC, it says, get a different color here. So this one here is saying that this and this are equal. Okay. And then it says right here on 4 and 5, it has to go from congruent to the measurements are equal. Okay, notice that number 4 is the same as 2, and number 5 is the same as 3. It just says equals instead of congruent, because you have to change it from congruent to equals for you to be able to say that the other parts of the angles are equal. So now, if you look at the next one there, number 6 and 7, now it's saying that if you add the two little ones together, you get the big one, and that's angle addition postulate. And then they're going to substitute in and do a little bit more there. Okay, like I said, I'm not going to spend too much time on that, but you can kind of look through that, because this is not what you're going to have to do. You're not going to have to fill that whole thing in. And so we'll see some more here in a minute that we can look at. Okay, all right, this is one of the more important parts of this, is understanding how to use vertical angles and some other things that they're going to be showing you in this. Vertical angles, linear pair, we'll learn about here in a minute. All right, but what this is saying is, what is X? Okay, you got this picture. I'm not going to read it all, but just look at your picture and notice this. You got this line here, and you got this line here. Okay, anytime you have two lines that cross, they create vertical angles. So where are the vertical angles in this picture? Well, this angle here and this angle here. Those are vertical angles, so those are equal. Now, this one over here says X, so I don't know what that is, but over here it tells me that the top part here is 11 and the bottom part's 11. So that's 11 and 11. That's what it's saying here. So it's 11 degrees and 11 degrees. So if you add 11 plus 11, that's 22. So this is actually, the whole thing here is 22. And because those are vertical, they're equal. So X equals 22. You're finished, and that's it. Nothing trickier than that. Okay, because they're vertical angles, they're equal, and that's how you find them. So really, just knowing the definition of vertical angles. Sorry, I shouldn't have skipped that. Back to this page, we need to do the second circle and the third circle. Okay, again, you got two lines that cross. You got a line here. Anytime you have two lines cross, they create vertical angles. You got these two here and those two there. Now, we're only looking at what they give us here. So these are vertical of each other, so they're equal. So you set them equal. So you're going to go 6x minus 45 equals 4x plus 5. Then just use your algebra skills. So anytime you have x's on both sides, get them on the same side. So I always take the smaller one and get rid of it. So I'm going to go minus 4x. But I got to do that over here too. If you do something to one side, you have to do it to the other side. So on the left side, 6x minus 4x is 2x. Bring down the minus 45 equals. On the right side, those cancel, and I get 5. Okay, now, once I got all the x's on the same side, get the x by itself. So take this 45 and add it to the other side. So I get 2x equals 50, and divide by 2, I get x equals 25. Okay, and that's all it asked for, is what was x there. Now, let me go down here and see. Okay. Now, if it asks what the angles were, and it might do it in the next one, I'm not sure, but if it does, you just plug 25 in over here, and you would get the angles. You can figure that out on your own. That's not that difficult. Okay, let's go to the last little circle here. And you got the same thing, okay? It says find the value of x and the measure of each labeled angle. All right, so same thing is these two are vertical, so they're going to be equal to each other. So you're just going to go 8x minus 20 equals 5x plus 37. Don't make this difficult. It's pretty straightforward. I get the x on the same side, so go minus 5x. That's going to give me 3x minus 20 equals 37. And then get the 20 over here by adding it. So it's going to give you 3x equals 57. And divide by 3. And you're going to get x equals 19. Now notice it says and find x and the measure of each angle. So now bring that 19 over here. I'm just going to plug it in right here. So it's going to be 8 times 19 minus 20. Okay, so if I go 8 times 19, be what, 152, so it'll be 132. I believe I did that kind of fast. Let me check it on the other one now. So if I plug in 19 over here and the one on the right, it should give me the same thing. So if I did that, that would be 5 times 19, which would be 95, plus 37, that would be 120, 132. Yeah, so that is correct. So 132 degrees. All right, so that's not that difficult. Just got to do a little bit of algebra there. Let's go to the next slide. So this next slide is just giving you a little information. It says congruent supplements theorem. And here's what it says. It says if you have two sets, well, actually 3 angles, and 2 sets are equal to 180. By the way, supplementary angles mean that they equal 180. So this means equals 180 degrees. Supplementary angles equal 180. So if you got angle 1 and angle 2, and you add them together, and they equal 180, and you got angle 3 and angle 2, add them together, they equal 180, then that means that 1 and 3 have to be congruent. They have to be equal. That's it. So if you got 3 sets of angles and 2 of them equal 180 and another set of 2 equal 180, then the 2 that are not the same are equal to each other. So main thing here in this is remember what supplementary means. It means equals 180. Okay, the next one is complementary angles. Complements equal 90 degrees. So it's the same deal as if you got angle 1 and you add angle 2 to it, it equals 90. If you have angle 3 and add angle 2 to it and it equals 90, then 1 and 3 are congruent. Again, probably the main thing you really need to get out of that is that complementary angles equal 90 degrees. That's going to be important. Okay, the next part here is on paragraph proofs. Now, paragraph proofs are a type of proof that you can use that we're not going to use, but you might see one in a problem. So I just want to show you what they look like. So look at this thing we're trying to prove here. It's given us that angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. So we want to prove that 1 and 3 are congruent. Okay, so they're going to use a paragraph proof. So just look down here. So I've just clicked on the solution, and here's what it looks like. So what they do is write it as a paragraph instead of 2 columns. It says, so by the definition of supplementary angles, measurement angle 1 plus measurement angle 2 equals 180, and measurement angle 2 plus measurement angle 3 equals 180. Okay, so where do we get the supplementary angles? Well, it told us there right at the beginning. So it's just writing a paragraph, and then it says since both of them equal 180, so since these 2 sets and these 2 sets equal 180, they're equal to each other. So they set them equal to each other. Then you subtract angle 2 from both sides, and that's going to give you angle 1 equals angle 3, which is right here. And then if the measurements are equal, then they are congruent by the definition. So it's the same kind of stuff, but it's just written in paragraph form. Okay, so at most you might see a paragraph proof, or you got to fill in a blank somewhere. Like it may say, like this last part, it may say by the definition of congruent angles, blank. Then you would just have to fill in angle 1 is congruent to angle 3 or something like that. Okay, I'm not even going to look at that second one because, like I said, we're not going to do paragraph proofs, so I'm not looking at the second circle. I know there's one there. Let's go on to Theorem 1.4. Theorem 1.4, sometimes theorems and postulates, for that matter, are just common sense. If it says, if you got 2 angles and they're both right angles, then they are congruent. That's what this is saying. I mean, that's just common sense. So if you got a right angle here, a right angle here, they're automatically congruent. I don't have much, it's not much more I can say about that because that's it. Just common sense. Now this one is kind of common sense, but you got to think about it a little bit more. It says if two angles are congruent and supplementary. Okay, so think about that for a minute. What does it mean to be congruent? Well, that means the same. But what does it mean to be supplementary? I told you that in a slide earlier. Supplementary, what does that mean? It means it equals 180 degrees. 180 degrees. Okay, so if two angles are congruent and supplementary, well, they're congruent, they got to be the same, and they have to add to equal 180. So if you have two things that are the same that equal 180, doesn't it have to be 90 and 90? That's the only thing that are the same and they equal 180. So that's what this is saying if two angles are congruent and supplementary, then they have to be right angles. And remember, right means 90. Okay, again, just the common sense theorem. Let's keep going. Okay, linear pairs. This is a good one here that you really need to know. Linear pair, think about that, what that word is saying. Linear has the root word line here. Okay, a straight line. And a pair means two. When you talk about a pair of something, it means two. So two angles on a line. So look at the picture they have here. You got this angle 1 and angle 2 here. They're both on a straight line right there. If you got two angles on a straight line, then they're going to equal 180 degrees. Why? Because a straight line always equals 180 degrees. So if I move this thing around, I can move it around whichever way I want to. So the blue and the reddish orange there is going to always equal 180 because both of those angles are on a straight line. Okay. Again, that one's kind of common sense too. So write a proof using a theorem. So let's look at this, a couple more proofs here, and then we should be to the last questions on the back. All right, so here's what we're doing is it says given that angle 1 is equal to angle 2 and angle 1 equals 105. The question is, or not a question, but you're trying to prove that angle 3 here is 75. So you want to prove that. Okay, well, just think about it. Before we even look at the actual proof of this, let's just use some common sense. So if angle 1 and angle 2 are congruent and angle 1 is 105, what's that make angle 2? 105. That's what congruent means, right? Okay, now what do we know about angle 2 and angle 3? They're right next to each other, so angle 2 and angle 3 are a linear pair. Right? Because we said a linear pair are two angles that are on a straight line. See this straight line here? So angle 2 and angle 3 are a linear pair. And what do you know about a linear pair? We said they equal 180. So angle 2, we'll put measure angle 2 plus the measurement of angle 3 equals 180. And what do we know that angle 2 is? We said it's 105. So I'm going to substitute 105 in for angle 2. And if I want to figure out what angle 3 is, I'm just going to subtract. I'm going to solve this little equation I've got started here. So that's going to cancel. So the measurement of angle 3 equals 75. So I just proved that, but I didn't do it in a two-column proof. I just did it just working it out over here. All you're doing, all a proof is taking all this stuff that we just did right here and making it more organized. What I did over here is not wrong, it's just not organized, and they want you to organize it. And so I'm gonna hit the solution, and let's look and see how they organize it. So if I just drop this thing down, the first part is given, the second part is given. Notice there was two givens here, so I had to put both of those in there. Now, it's okay if you put both of them in the first step and just write given, you can do that. Just put a comma here, that's fine. All right, then, since angle 1 is equal to angle 2 and angle 1 is equal to 105, then those two are equal to each other by transitive property. Again, that goes back to that. If A equals B and B equals C, then A equals C. Okay, and then from there, they said angle 2 and angle 3 are linear pair. Didn't we say that over here? That's what we did over here already. So again, you can do this. It's just organizing it is where you gotta be careful here. Okay, now since they're a linear pair, we can say that they equal 180. If you add them together, that's what the linear pair theorem says. And that's what we did. We set them equal to 180 over here. And then I substituted, by substitution, number 6 there, 105 in the place of angle 2, and then I did subtraction property of equality to give me 75. Okay, so all it is instead of just working out the problem, you got to put it in 2 columns and give it a little more organization. All right, let's look at the second circle here. All right, so if you do this one, it's basically the same way. I'm not going to go through it all the way, but just talk to you a little bit. So the given is angle 4 is 35. Angle 1 is equal to angle 2 plus angle 4. So angle 1 is equal to angle 2 plus angle 4. Don't really have a way to write that out just yet. But here's what we do know. What do we know about angle 4 and angle 2? There's 2 straight lines that cross, so they're vertical angles. So angle 2 is also 35 because they're vertical angles. Okay. Now, what else can we get from that? Again, we're looking to see what the angle 3 is 70. Well, remember it said over here that angle 1 is angle 2 plus angle 4. So if you add 2 and 4 together, you're going to get 70, right? Angle 2 plus angle 4 equals 70. So angle 1 equals 70. And then look, angle 1 and angle 3, what are those? Those are vertical. So angle 3 has to equal 70 because vertical angles are congruent. Now, you can go in there and you can click on the solution and figure out how exactly to type that up. But just wanted you to see that you can figure that out. You don't have to type all that mess in. Or I mean, you don't have to do the full proof to figure out the solution. Now, the proof is just the organization of it. All right, so right here's just some notes. You can look over that. So let's answer these last few questions and we'll be finished with this section. All right, so here, the essential question: how is deductive reasoning used to prove a theorem? All right, remember, deductive reasoning is when you take facts, use facts to find a solution, okay? Might be a statement like this: if you study hard, you will make good grades. All right, and then someone says, well, Johnny studies hard. Then what can we say about Johnny? He will make good grades. And that probably not a good example because that's not always true. Sometimes you can study hard and still not make good grades, but that is kind of the basis of deductive reasoning, though. Take facts and use those facts to answer questions. Inductive reasoning is when you take a guess, like it's take an average of something and you just say, oh, well, I think this is going to happen next. All right, kind of like the stock market. When they do that, when they decide how the stock market's going to go, they just use and find a pattern and see what they think is going to happen next. They never know for sure. Okay, let's look at the second circle here. All right, it says, Jaden states that based on the congruent supplements theorem that angle 1 plus angle 2 equals 90, and if angle 1 plus angle 3 equals 90, then angle 2 is congruent to angle 3. What is the error in Jaden's reasoning? So if you look at that carefully, it looks like it's good. I mean, because if angle 1 plus 2 is 90 and angle 1 plus 3 is 90, then you can mark out the angle 1s, and so angle 2 and angle 3 must be equal to each other. Okay, so it looks good, except there's one big word here that's a big mistake right here: supplements. The congruent supplements theorem. If you remember, supplements equal what? It's 180, right? These equal 90. So what word should it be? It should be the congruent complements theorem. That's the mistake. He should have put complements there instead of supplements. All right. Oh, I messed up, hit the wrong thing. All right, let's go to the third circle. Okay. How is the theorem different from a postulate? A theorem is something that has to be proven. A postulate is something that's assumed to be proven. It's already, you don't have to prove it. It's assumed that it's true. And then it says, how is a theorem different than a conjecture? Well, a conjecture is just a guess. A theorem is something that can be proven. Conjecture may or may not be proven. It may or may not be true. Okay, and then the last one here, if angle 2 and angle 3 are complementary, how could you use the vertical angles theorems to find angle 1? All right, so what does complementary mean? It means they equal 90, right? So what's this? It's really simple if you just kind of follow through here. So what do we know about 2 and 30 degrees? Those are vertical angles. They're right across from each other, two straight lines. So that means angle 2 is 30. I can put that in there. All right, it says that angle over here, it said that angle 2 and 3 are complementary. So these two together right here have to equal 90 degrees. So what does that make angle 3 there? Well, I would have to go 90 minus 30, and that would equal 60. So angle 3 is 60 degrees because 30 and 60 make 90. Okay, it's got to be 90. All right, then look at 3 and 1. Those are vertical, so they're equal. So if 3 is 60, then 1 is 60. And so the answer is 60 degrees. So you can use vertical angles to find them that way. All right. And now let's go to this last page that we need to do here. Okay. Number 5 says, what statement could you write in a proof for measure angle ADC using the angle addition postulate? Okay, so let's look at that. What kind of statement? So here's measure of angle ADC equals, if we're using the angle addition postulate, remember that says that if you take two angles, add them together, they equal the whole angle. So what two angles added together give you angle ADC? Let me mark that over, ADC. So what two angles would give you that? Well, that would be this angle here and this angle here. What are those names? So I'm going to name this one with the 1 mark here. That would be ADB. So measure angle ADB plus, and then the one with 2 marks down here, I'm going to name that BDC. And that's it. That's how you would use it, is you would say that this big one is equal to these two little ones added together. That's what the angle addition postulate means. It means you add the angles together to give you one big one. Oh, I hit the wrong button again. Sorry, keep doing that. All right, the second circle says, could you use vertical angle theorems as a reason to prove that angle ADC, which would be that angle, is equal to angle EDG, which would be that angle? Yes, absolutely, because those are vertical angles. If you look at them, you see if you got this line here and you got this line here that make those two angles. So the answer would be yes, because they're vertical angles. All right, let's look at the third circle. It's going to keep using this same picture here. It says given that angle ADC is 90 degrees, so ADC is 90 degrees, what reason could you give to prove in a proof to state the angle ADC and angle HJK, which is this one over here, are congruent? Well, remember that common sense one that we had that says that if two angles are right, then they're congruent? Well, that's it. That's what we would use, is the right angle theorem. And that's it. So again, that's just that kind of common sense one. And let's go to the last one here. Now this last one's got a picture for us, but it says the leaning tower of Pisa leans at an angle of about 4 degrees, and see that in the picture, from the vertical. And then as shown, what equation for the measure of x and the angle it makes with the horizontal could you use in a proof? Okay, well, when it says vertical, it means straight up at a 90-degree angle. So that means that this red dotted line here is straight up at 90 degrees. This is 4, and x is the rest of it. So you could take x plus 4, this x plus the 4, and that should equal 90 degrees. There's your equation. That's it. That's your answer to that. That's the equation you could use. You could go x plus 4 equals 90 degrees. All right, and that is the end of this part.